Hello everyone, and thank you for attending today's webinar, Cellular IoT, a Consensus Around Leadership Emerging, sponsored by InterDigital. Before we begin, I wanted to cover a few housekeeping items. On the right-hand side of your screen is the Q&A. If you have any questions during the webcast, you can type your question into the Q&A box and submit your questions to our speakers. All questions will be saved, so if we don't get to answer you, we may follow up via email. At the bottom of your audience console are multiple application widgets you can use. If you have any technical difficulties, please click on the yellow Help widget. Here you can find answers to common questions. A copy of today's slide deck is available for download in the green Resource List widget. Towards the end of today's presentation, we'll ask for your feedback. A survey will pop open on your screen and will only take 1 minute to complete. Your feedback is extremely helpful. An on-demand version of the webcast will be available about 1 day after the event and can be accessed using the same audience link that was sent to you earlier today. I would now like to turn the event over to heavy reading Steve Bell. Steve?
Thank you very much, Kelly. Good morning, good afternoon, and welcome to everybody to this webinar on Cellular IoT, a consensus around leadership emerging, sponsored by Chordant and InterDigital Business. I am joined today by a very distinguished and experienced crew of speakers. Among the first is Mike Jeronis, who is with Chordant and InterDigital Business. Mike is responsible for leading a team of architects, advanced data management systems, and he's got extremely good credentials in terms of engineering and organizational management. Prior to joining Chordant, he led the InterDigital ASIC and DSP organization, and he was responsible for chipset design and development of the InterDigital Slim Chip product. He has 20 years of career experience before InterDigital, where he was developing satellite-based communications with Lockheed Martin. I'm also joined by Ken Bednasz, who is Vice President of Application Engineering for Telit, and he's responsible for the technical support and module certification for Telit's product. Ken has also been with Telit since 2006 and has been instrumental in leading the innovative product introductions within the North American market. So, gentlemen, welcome. Thank you for joining me today. We have a very interesting hour in front of us. And I will lead off by sharing with everybody the results of a heavy reading survey that we conducted in June of this year that looked at responses from 87 CSPs from around the globe. 30% of which were mobile operators, 36% converged and fixed mobile operators, and a mixed variety of other MSOs, fixed and virtual network operators. We conducted this on a global basis with a geographic mix of 55% from the US and 45% from the rest of the world. Europe representing 17% and Asia Pacific 15% as the other large regions. We were interested in identifying what people thought in terms of the revenue they were gaining from IoT services. And what we saw was that about 7% of people thought that they didn't have any revenue from M2M or IoT. About 19% saw less than 1%. But we saw over sort of almost 50% believing that their revenue was between 1 and 10%, with another 12% believing it was over 10 to 15. To give a reference point, I think that there's a real issue in terms of the industry as a whole overestimating their revenue. If you look at AT&T and Vodafone, probably the two largest players in the market to date, and obviously Verizon and Telefonica and Orange are other significant players, but both of those two are approximately about $1 billion of revenue, which when you look at it relative to their other revenue is certainly less than the 1% level. So I think there's a tendency to overestimate the revenue from IoT. Certainly there's a focus on connectivity and the number of devices that are being connected, but that's not necessarily translating into monetization. And I think that's part of the issue. The other part of this is that in most cases, most operators aren't actually sharing that number. And so both, I think, internally as well as externally, there's confusion and doubt in terms of how much revenue is actually being generated by IoT, which, given the focus of IoT as a sort of critical use case going into 5G, means that I think the industry has to become a little bit more aware of the realities. Having said that, we also found out where they were getting their revenue from, and the most this was a weighted average. So we asked, the question in terms of the, what was very important, slightly important, and not of no importance, and then weighting it. Transport and logistics was the prime mover of revenue, followed by industrial IoT, smart cities, and smart buildings. There was actually quite a diversity across the different regions and also the different types and the sizes of the CSPs. We don't have the opportunity to go into the detail here, but there was diversity in terms of which markets were seeing what. What was interesting, I think, is given the attention that is focused on the connected and autonomous car, that it was really one of the least rated sources of IoT revenue. And this may well be because of the fact that most car companies have contracts with the larger global players, obviously because of the aspect of management of the SIM and ranging the roaming and data delivery services in different countries. And so maybe when you look at it from the diversity of operators and diversity of countries, that's not quite so surprising. We also asked what the market was going to be in terms of 2018 in terms of importance. And here, industrial Internet of Things jumped to the top with a significant shift in terms of the numbers. Healthcare followed that, and then consumer IoT. But again, really, connected car was still down at the bottom. Smart homes also, and I think that's an interesting one because initially there was a belief that because IoT was going to be about smart things and smart devices that could be related to consumers, that would be a simple sale to consumers in terms of IoT in the home. But experience has shown that that's a very complex sale. Consumers are not that familiar with different types of connectivity, whether that's Bluetooth or whether it's an 802.15.4 thread or Zigbee or Z-Wave. These type devices don't always interoperate easily, and there's a huge amount of interaction and support that if a service provider is providing those elements, they get sucked into. We also then looked at the importance of the functionality. So in other words, what is it that you're really sort of focusing on? And the most important element that came through resoundingly was in a weighted average of out of 3 with 2.76 was security. And that's not surprising. I mean, it's the most vulnerable aspect of any relationship and also reputation. And so focusing on that, I think, is a good indication. But it's also one of those things where certainly in the mobile space, mobile operators have prided themselves on the ability to provide security over a long period of time. And so that may be a mechanism for extending value beyond connectivity in terms of security services. Obviously, connectivity provision, management and device management are key. And also the aspect of data and device management together with the provisioning. And that's linked to the deployment of application enablement platforms, which was an area that the GSMA identified as a large growth area. If we look at two of the other areas that are lower down, but with very similar ratings, systems integrator and billing, I think this actually surfaces a dissonance in terms of the way in which service providers are looking at this. Billing is a natural capability that most service providers, both fixed, virtual, and also mobile, have been doing for a number of years. They know how to do that. They have the billing systems. They have the system capability. And they, 55% rate that as a very important area and 38% as a somewhat important area. What's kind of surprising is that systems integrator was rated with a 54% as very important, and also around 41% as somewhat important. That is not a natural area for a service provider. It's a complex area. It requires vertical market knowledge and skills. It requires different skill sets and different support mechanisms. And so that is as a function area is a complex one relative to delivering on billing services. Another area that came out, I think that is worth focusing on, is clearly within an IoT world, ecosystems are extremely important. And being an ecosystem orchestrator is fundamental. And there seems to be insufficient thinking around this. The challenge that CSPs face is in transitioning from a business model where they are delivering a singular solution to one where they've got to partner and work with others to deliver into the IoT market. There are very few situations where it's a completely standalone end-to-end solution, and it's necessary to develop, curate, and orchestrate an ecosystem of partners that can provide these diverse customer segments with the individual solution needs. We also looked at IoT access technologies. And what was interesting was what were the priorities in terms of the various operators. And LTE-M, one of the new mobile IoT technologies that emerged in the last couple of years, was very, very highly rated. But just behind that was 5G and then narrowband IoT. The fact that you're starting to see 5G in there is a combination of things. One is, I think that, obviously LTE-M and narrowband IoT as mobile IoT technologies have been, promoted by GSMA and accepted by 3GPP as use cases and developments that will continue to evolve under the 5G umbrella. So that's good. One of the questions is, are operators really starting to see IoT as a key part of 5G, as their 5G deployment, because of what they need to be able to do with the rest of the network? That's not necessarily clear, but what is clear is that 5G is in that mix as an IoT access technology. I think the other thing of note is that LoRa Alliance is almost being seen in the same sort of light as extended coverage GSM, where as a sort of a low-cost, non-cellular alternative to GSM, whereas, and it's certainly sort of seen as a distant relative to the Sigfox and other LPWA technologies, which could obviously also include Wi-Fi as well. So in terms of timeline for supporting each of these technologies, what you see on this chart is that LTE-M, 33% of the respondents saw that they would be deploying that in 2018. 30% saw 5G in 2018, which again, knowing the timeline for 3GPP and 5G, that seems a little bit sort of optimistic. But it may be that they're talking about the support mechanisms that are around it. Narrowband IoT was 22% in the 2018, but accelerating to 33%, so around about the same proportion as LTE-M. And then obviously as time goes on, they tend to sort of decrease in terms of the intensity as 5G takes over. The other area that we looked at was to try and determine what standards were important to service providers, because if you're dealing with an IoT market, it's not just about cellular, it's obviously about a broad base of other standards bodies. And so we asked the respondents to rate the different standards bodies and initiatives. What you can clearly see is that the 4G, 5G, the 3GPP, GSMA, NGM were seen as the predominant standards group that's impacting the deployment plans. ITU, obviously with ITU-R, is the sort of the master plan that 3GPP feeds in terms of the 5G plan. IEEE and IETF, the heterogeneous network of concept of 5G means that both of those standards bodies, because of the different Wi-Fi technologies and other technologies, are linked into that 5G process. What's interesting, it clearly is that the Industrial Internet Consortium was rated fifth in terms of importance, which I think is beginning to reflect the degree to which industry is recognizing the huge opportunity of digital transformation and digital automation in enterprise, factories, and industrial applications. And the Industrial Internet Consortium has done a phenomenal job in providing frameworks and material and bringing together an ecosystem to drive the different aspects of promoting that. So in summary and the key takeaways, the IoT market is still at a very early stage for CSPs, and there are differences that exist both depending upon the size and also the region. We saw that in terms of some of the large and smaller operators and how they're approaching the market in terms of functionalities that they're deploying. Some of the highest priority segments in the next 3 years, clearly industrial IoT is the number one, and so therefore, as I said, is no surprise that IoT Consortium is ranked fifth in terms of the important standards bodies. CSPs seem very positive in their deployment plans for access technologies, but less so about their IoT functionalities. And this indicates that they have a long way to go before they truly start to address the gap between the revenue opportunities and just providing pure connectivity. And this is evidence that many of the CSPs have not yet seen the need to partner. The ecosystem issue is a real one, both with customers to deliver complex integrated solutions and with vendors to bring together a holistic end-to-end offering. And so with that, that's the end of my presentation, but we have a poll question. I'd be interested to know from our audience, did the overvaluation of IoT revenue contribution surprise you or not? So a simple yes, no will sort of be interesting to see from your perspective. And then as we're sort of waiting for that to come through, Mike, if you come onto line, what's your feeling on that? Were you surprised by that result?
Not necessarily. I think that what they consider what companies are considering revenue from IoT may encompass a lot of different aspects. So I could see where potentially it would be estimated to be a higher value than maybe it is.
Let's see what the audience thinks. So 64% weren't, 65% weren't surprised. So that's interesting. So I guess there must be a general belief out there that everybody's overestimating it. So with that, Mike, the floor is yours, and we look forward to hearing your perspective on things.
Okay, thanks, Steve. Appreciate it. Hello, everyone. My name is Mike Jeronis, and I'm responsible for Chordant's IoT platform product development. Today, I'm going to talk a little bit about the IoT market, connectivity options available for different IoT use cases, and the justification for the push of LPWAN technologies in 3GPP. A quick intro for Chordant's products. Chordant is a 1M10 based IoT service layer that accelerates the development of complex IoT use cases. A good example of an application deployed on top of the Chordant platform is our commercially available data marketplace called OneTransport. And if you're interested in more information on that, it can be found at onetransport.io. For those unfamiliar with 1M10, 1M10 it was referenced in Steve's list of standards. 1M10 is a global standards initiative for machine-to-machine communications and the Internet of Things. If you want to know more about 1M10, I suggest you can check out their website at onemtem.org to get a feel for the capabilities that the 1M10 standards body are specifying. So I'm going to start with I'm showing a forecasted growth in IoT connections and associated revenue challenges for CSPs. So hopefully you can see the box on the left. It makes a compelling business justification for the need of LPWAN technologies, specifically when you compare the growth rate of the next 10 years between traditional IoT, mobile IoT connections and LPWAN connections. These types of projections have certainly impacted the urgency for 3GPP to accelerate the development of Cat-M1 and narrowband IoT. The graph on the right shows that over that same time period, the revenue generated by providing connectivity drops as the number of connections rises. And this is the challenge that CSPs will face if they only provide connectivity. This projection can serve as a motivation for CSPs to consider strategies to move up the value chain, and I'll talk about that in some upcoming slides. So I'm on my third slide, which is this graphic. This graphic identifies many different IoT connectivity options available to application developers. I like it because it clearly shows that IoT use case developers need to consider the benefits of each of these when they start to design their services. Vertical axis is throughput and horizontal axis is range, and it's clear that there is not one technology that satisfies this full space. Another takeaway from this graphic is that the latest 3GPP developments have strongly positioned cellular as the dominant technology for IoT by focusing on three key 5G use cases, which are enhanced mobile broadband, massive machine-type communications, and ultra-reliable low-latency communications. The next generation of cellular will be well-positioned for a multitude of IoT use cases. And as Steve mentioned, it's also worth noting that Cat-M1 and narrowband IoT, which fall into this LPWAN block or area or characteristics, and are available today throughout the world, are also considered 5G radio technologies. So this next slide is in this graphic I've tried to overlay a set of representative IoT use cases and map them based on rough approximations of their throughput and their range requirements over the top of the connectivity options. So as an example, you can see that maybe a smart parking application doesn't require the same bandwidth as a connected vehicle solution. In fact, the underlying device technologies will significantly differ from each other, as devices used for smart parking will only transmit information on an event trigger such as a spot, parking parking spot becoming available or being occupied, whereas a connected car may be transmitting continuously. So additionally, there will be differences in device pricing and battery life requirements. As you can see, also a lot of these, each of the properties of these connectivity solutions will be leveraged by different or appropriate IoT use cases. So as I mentioned earlier, one of the key 5G goals is to enable massive IoT. And as I showed in the market projections, the largest amount of IoT connections will be low-power wide area connections. And some of the attributes of low-power wide area connectivity are small payloads, which results in lower data volumes, infrequent transmissions that also result in lower number of messages, long battery life requirements of the devices and sensors that are deployed, low cost of those devices and sensors, and low cost / non-complex devices as well, since there will be high volumes of these devices. Due to this, LPWANs are optimized for constrained devices and communications with these devices. And technologies need to be deployed by the network servers to provide the mechanisms that will reduce the interactions between devices and the network. For example, in 3GPP, we have the power savings mode and extended DRX as examples of technologies that will allow devices to sleep longer, stay connected in idle mode, things like that will save power in the long run. Additionally, because devices will be constrained for cost reasons and will likely not have the capability to handle heavy handshakes like HTTP TLS require, simplified communication methods are required, such as non-IP based communications. Again, these are results of the common attributes associated with these types of use cases. And I guess one last point, hopefully another point that's obvious, is that many IoT use cases will be utilizing multiple radio networks. For example, it's feasible that a use case may combine cellular or multiple different cellular radio technologies, could be LoRa, could be other types of radio networks to realize an application's end goal. This is a great example where one M10's based IoT Service Layer is a benefit to application developers due to its ability to interoperate with many disparate network servers, thus significantly reducing the complexity that the application developer is required to deal with. So I talked about the IoT Value Chain. And here is a representation of an IoT value chain. As I mentioned earlier, CSPs will be faced with a revenue challenge if they don't move beyond providing connectivity as the IoT market grows. So one could argue over the accuracy of these percentages, but I think it's clear that the higher value will be found as one moves up the chain, or to the right in this case. There are examples of some CSPs already moving up the value chain, and some strategies may make more sense than others. For example, further abstracting the complexity of the core network through the integration of a service enablement platform would accelerate application developers' efforts, thereby bringing more connections to that CSP and additional revenue by offering the service enablement as a value-added service. Traditionally, MNOs or CSPs have not been very successful in offering services, but they are well positioned to try to do so. And finally, one approach for CSPs could be a seamless approach for CSPs to move up the value chain is to add a service capability server to the core network. And open standards-based SCS, such as 1M2M, would enable CSPs to offer a set of value-added services to enterprises developing IoT applications. 1M10 has developed a set of common services that span across multiple IoT use cases. The horizontal approach enables applications to discover and share data across multiple verticals, thereby creating new source of revenues and services. Chordant's scalable IoT platform satisfies these goals and provides CSPs and enterprises with the tools to enable the next generation of IoT applications. So thanks, Steve. That wraps it up for me.
Thanks very much, Mike. Interesting presentation, and I think you were reinforcing some of the points I was making. I'm kind of interested also in terms of how our audience is thinking about the promise of IoT and 5G. So are they excited about the promise of 5G for the Internet of Things? I'd like to sort of get a feel for that since it sort of came out in our survey. And with that, I'd also like to sort of welcome Ken to get his perspective on it. Are you seeing any interest in terms of people at least inquiring about 5G chipsets and when they might be available?
Hi, Steve. Yes, absolutely. I think there's a lot of excitement around 5G because it's bringing new dimensions to cellular and 3GPP that have not been seen before. And I think the focus around low latency, high capacity are some of the key areas that are exciting people. Okay,
well, let's see if the audience agree. Wow, 77%. Very high amount. Only 7% no, and 15% not sure. So I guess the jury's not out on that one. So with that, Ken, I'll let you take over and tell us about what's happening from your perspective in terms of future-proofing IoT.
Great, thanks, Steve. My name is Kenneth Bednasz. I'm the Vice President of Application Engineering at Telit. And to give you a little background about Telit, we are a leading enabler of IoT. So we offer IoT modules and IoT services. When it comes to IoT modules, we offer a variety of technologies. Just like Mike mentioned, there's a lot of different technologies that are used out there for IoT. Everything from cellular, which could include 2G, 3G, 4G, 5G, or the other variants with Cat M1 or narrowband 1, but we also offer the Wi-Fi, Bluetooth, other forms of LPWA and location products. So we offer a wide range of IoT modules to kind of fit different use case needs. On the IoT services front, we offer connectivity with leading mobile network operators around the world, along with a platform that helps with device management using lightweight M2M protocols. And so what we're trying to do here at Telit is really provide building blocks to our partners to allow them to create robust and secure solutions that lead to shorter times to market or shorter times to revenue. So what are the key requirements for IoT and 5G? What is different than what we've done in the past? And there's really a focus around a few new areas that needed to be solved, a few new challenges. We hear a lot about reducing size, cost, power, and that's definitely one aspect of it, but also coverage. Coverage is really key, where traditional cellular technologies did a great job for cell phone use cases and reaching into buildings, but maybe did not do a good job, penetrating into basements where IoT devices could be located in the parking garages or underground for water meters. And so there's some specific enhancements within 3GPP and 5G to help extend coverage with technologies like CE Mode A and CE Mode B. There's also a big focus around reduction of power consumption. How do we get these IoT devices to last 5, 10, 20 years? Mike touched on it, how we have some new technologies with PSM, which is power save mode, and EDRX mode. And so I'll talk a little bit later today on how those two technologies work. Cost is obviously a key driver too. We've been using cell phone technology, and it's not really focused around the low-cost needs of IoT. That has definitely changed now with the introduction of Cat M1, narrowband 1, and with the movement forward to 5G. Security is another key aspect. As we talk about IoT controlling infrastructure management, maybe the electric grid or water systems for utilities. We definitely need security to be front and foremost, and that's definitely being built into the new standards. Data throughput, I think it's more than just data throughput, it's different connectivity options, whether it's data or voice, and so we do see voice being added to some of these new IoT technologies. When it comes to throughput, 4G and 5G are doing a great job of having very low data rates to very high data rates, and 4G offering gigabit LTE technology today ahead of the introduction of 5G data rates. Scalability and capacity are obviously key. How do we scale technologies? And I think the movement from IPv4 to IPv6 is really critical for IoT. As there's a massive number of devices out in the field, IPv6 is going to be key, making sure that all these devices can coexist. And so we're definitely doing right things here when it comes to IoT and 5G. The other focus is really around use case. How do we address all the non-cell phone use cases, whether it's all the different vertical markets that Steve talked about, whether it's smart city or e-health with wearables, drones or vehicles, whatever it may be. We needed some advancements in the requirements and technologies that are used within cellular, and we now have that with 4G LTE and the movement to 5G. Then, of course, interoperability. I think interoperability is really key. There's no way to really scale these technologies and these deployments around the world without having interoperability, and nobody has done interoperability better than 3GPP and cellular. So for me, I've been in the cellular IoT business for over 15 years, and in the last 3 years have been the most exciting for me. I think the momentum and the number of IoT deployments has grown so significantly that we are now creating these technologies that we're talking about today, which are geared for and designed for IoT. So we're no longer taking cellular phone technologies and trying to shoehorn IoT devices using these technologies. I mean, we have the cell phone technologies that have been great and carried us the last 15 years, but we're too big now to not have our own technologies built within 3GPP like category M1 and narrowband 1 to kind of take the next step forward. Some of the challenges with the cell phone technology is it's really designed for cell phones. And so, we talked on the previous page about coverage limitations, power consumption limitations. A lot of those are being addressed. And it's very clear that narrowband 1 and Cat M1 are part of the 5G transition. So I think as we took those poll question earlier on, there's showed a lot of interest around Cat M1, narrowband 1, which was expected, but also there was interest around 5G, and I think that's coming from two ends. I think that's coming from the high data rate end that you hear advertised with the TV commercials from the leading operators around the world, then also on the low end with narrowband 1 and Cat M1 being considered part of the 5G standard. So as far as the introduction of some key 5G components, I think that if we start from the bottom and work our way up, the mobile IoT with narrowband and Cat M1 is available today. We are seeing a large number of deployments using these technologies around the globe today. Network operators, committed to this technology about 3 years ago, and they have had nationwide and live networks for the last couple of years. So it's definitely gaining the momentum that we expected. The next step is the 5G that people typically think about when they hear 5G is the high data rates, millimeter wave frequency to have ultra high bandwidth, high data throughput technology. So we see the enhanced mobile broadband happening today. We see enhanced mobile broadband really being a replacement for the last mile of fiber. So reaching areas instead of trenching connected fiber lines, we see 5G and mobile broadband really taking over in those specific use cases. And then the next step, which we're just going to start seeing, is more the critical communication. So this is enhancements to public safety and low latency for the different use cases that we'll talk about. So we talk about where we've been and where we're going. We talk about, what are some of the solutions that 5G, or I should say challenges that 5G is going to solve. On the left-hand side, we talk about how the industry was fragmented. It was fragmented in many ways. One example is in the U.S. We had two technologies that we were working against. We were working against 3GPP and 3GPP2, and that's just one example where we've kind of standardized around 3GPP when it comes to cellular technologies, which is helping people scale their business. As far as complexity, technology, and businesses, we're talking about all different bands. When it comes to category 1 LTE and above, there's a lot of different bands out there that are used globally. The technology was designed for cell phone usage, and so what we've done is we've really simplified that with 5G. And then, like we mentioned and Mike mentioned earlier, the technology was not fit for a purpose. It was really designed for cell phones. It was not for IoT and M2M in mind. And so all these enhancements to reduce size, cost, power are really benefiting new use cases that we're going to see start to accelerate with 5G. And so we pointed out two new use cases here, specifically massive IoT, smart cities. So as we get into lighting and different sound detection and smart street lights, parking meters, we're going to see new massive IoT. When I talk to our partners about Telit, a day in the life of Telit is pretty interesting because you will probably pass by 5 to 10 different devices a day that are using IoT technologies with Telit inside, and so that could be anything from the parking meter at the parking garage or the parking meter downtown to the electric vehicle charging station to the vending machine that's taking a credit card and swiping that. So these are all IoT devices. So as you move throughout your day, you're probably touching Telit in many different ways. It could be inside vehicles, inside your home security systems, inside your thermostats, whatever it may be. So massive IoT is real, and it is happening. When it comes to mission critical is definitely exciting because it's all about low latency and high reliability. And I think the one vertical market that's going to benefit the most is autonomous vehicles. So I think we will see a lot of strides with autonomous vehicles over the next couple of years as 5G addresses some of the technology challenges that we've had. So I think one of the important things that I'm promoting today, I mentioned that Telit does a lot of different wireless and IoT technologies. Today we're focused a lot around the 3GPP standard, which is really important to have a huge ecosystem. We've seen a lot of other technologies come and die. For example, WiMAX is one of them. If the ecosystem is not large enough, a technology will not strive, a technology will not survive, and it will not be scalable globally. And I think what we have here with LTE and 3GPP evolving into 5G is a very sustainable ecosystem, so much so that we are looking outside the traditional licensed bands for cellular that we used in the past, even unlicensed bands. So 3GPP is starting to address more than just the traditional cell phones as it did before in the past, to not only IoT with Cat M1, narrowband 1, but also to unlicensed spectrum to adopt to different use cases. So I think the concept of 3GPP just being for cell phones is an old way of thinking. 3GPP moving forward is to do everything with IoT, licensed spectrum, and unlicensed spectrum. So definitely exciting times. As we talk about market trends, I'm just going to focus on the bottom three. There's definitely a movement away from 2G and 3G, and we've seen that happen in places like Australia, the US and Canada already, but also in other regions we do see that happening. In North America, for example, a lot of the 2G technologies have been sunset by network operators, and there's definitely plans for 3G sunsets in the future. And so for that reason, we moved to the second from last one, which is LTE category M1. We do see partners looking for alternate technologies as they move away from the legacy technologies, and category M1 is definitely number one on a lot of customers' lists because of the availability of the technology, because the technology offers mobility and coverage, low battery consumption, and also an option for voice. And so category M1 is going to be a feasible technology not only for IoT sensors, but also for IoT devices that need voice communications with VoLTE and voice over LTE. So as we get into the security markets, telematics markets with voice or landline replacements, category M1 will be a viable technology. And then last, really 5G. So we do see 5G playing a lot of different roles. Today we're focused more on the IoT aspect of 5G, but also high bandwidth and next generation mobile broadband with millimeter wave. That market will definitely be addressed by 5G, which is definitely exciting. So as far as, what are the main problems that 5G are going to solve? We talk about, massive content, and so we already touched on that with how we see 5G replacing fiber for the last mile with the millimeter wave, with the ultra wide bandwidth available with 5G and millimeter wave. I think the second one is really important, massive control. Massive control is going to allow the next generation drones and robots and autonomous vehicles to operate more efficiently and actually in higher scale and higher number of deployments. I think today we do see some drones and robots and automated cars working, but they're kind of working on legacy technologies where 5G will definitely address their needs with ultra low latency. And then the last one, massive sensing, and I think this is one of the most exciting parts for me is watching IoT really grow in terms of sensing. It can be anything from temperature sensors to sound sensors to air quality to location sensors. So we're starting to see a smart environment out there, a smart world where we can detect things ahead of time or detect things as they happen and not have to wait for somebody to call in that there's been a car accident, or call in that there's been gunshots, or call in that the air quality doesn't seem right. If we can detect those real time, we can respond and react a lot faster and save lives. And so from a Telit perspective, when we talk about our cellular modules and our IoT modules, we have a wide offering. We are really focused very heavily around Cat M1, narrowband 1, along with the legacy technologies like Cat 1, which is the lowest common denominator globally, or Cat 11, Cat 18, and moving to 5G in the high end. But what we offer is a full range of pre-certified modules which can be globally deployed. We offer a common form factor so you can scale between these technologies, because like Mike was pointing out, not one technology is going to fit every use case. But the nice thing about Telit is you can do a design once with regards to hardware and software, and you can plug and play different technologies. You can move all the way from 2G technology to 4G LTE to narrowband 1 to Wi-Fi to Bluetooth without having to do redesign over and over. And so that's our focus, is trying to enable the ecosystem to allow it to scale a lot faster. And so that's all I have for today. Steve, I'll pass it back to you.
Thanks very much, Ken. Great presentation, and I think it sort of brought to light a lot of different aspects from the for the audience to consider. We've obviously got some time for questions. Actually, Mike, there was one that I noticed. Somebody asked what the U in UMTC, or Ken, what U in MTC stood for. I think on one of your slides.
Oh, sorry, ultra reliable. So the U is for ultra. So ultra reliable, ultra critical. That's what the U is for. Yeah.
Okay. No problem. So Mike, as multinationals transition from 4G to 5G, what will be the impact on the IoT service layer, do you think?
Well, from a 3GPP perspective, I'd say that, well, I'll say this, that 1M2M in Release 3 is focused heavily on 3GPP interworking. So there's a block in the core network called the SCEF, which is Service Capability Exposure Function. And what that is a set of APIs that the core network is now exposing information to SCSs, or Service Capability Servers. And that SCEF component is specified in Release 15. It's a 4G technology. So it allows interaction and control of, for example, narrowband IoT devices. For example, you can deliver data, non-IP data versus that API. You can set up schedules for power savings mode, etc. That API, when they transition to 5G, will transition into something that's referred to as the NEF. And there's a strong motivation within 3GPP to make sure that the SCEF and the NEF, or the APIs that are exposed, are, I'm not going to say backward compatible, but are very similar to each other. So from an IoT service layer, and 1M10 is probably the only service layer that provides interworking with the 3GPP core network. I think the transition from 4G to 5G will not be that difficult from a service layer perspective.
Good. With the systems integration being reported by the survey, that I showed as very important, even just as important as sort of billing to IoT, how do you see operators reconciling this with their future business plans? And I guess Mike and Ken, you both see it from different sides, but be interested in your perspective.
Yeah, I can start. I think it would, I think a network operator could answer that more directly. I know each have different plans, but I think offering ways to help enable users of their network to more easily control device management, we definitely see that happen. We see there's definitely focus throughout the industry on device management and lightweight M2M, using standards to control devices. It's all about scalability. So I think network operators are looking to offer easier ways to use their network.
Yeah, I would agree with Ken. I think mobile network operators, if they offer a service enablement platform to their customers that will further abstract the technologies that are underneath of that would be a way for them to simplify and accelerate the development of IoT applications. And as Ken said, for example, lightweight M2M is a key technology for device management. It's also one of the goals of 1M2M is to really not recreate the wheel, but to interoperate with existing technologies. So 1M2M, for example, has a interworking with lightweight M2M as well. So that's one of the key technologies or at least that's a way in which network operators can simplify the development of IoT applications.
So it's twofold. It's platform and it's simplification, but I guess it's also having to work with an ecosystem as well, and sort of finding potentially. I mean, there is almost a case for a new type of systems integrator between the sort of the classic industrial and the classic IT systems integrator. Somebody that's emerging as an IoT systems integrator. Are you guys seeing that in any of the discussions you're having?
Yeah, I would say yes. I would agree with that. Obviously, there's a lot of aspects of pulling together an end-to-end system. Obviously, security is going to be a key element of that, and being able to develop. You're dealing with a lot of technologies, from devices all the way up to cloud. Applications in the cloud. So there are definitely, I think, system integrators that are focusing on IoT systems.
Cool. Another question on integration, but a slightly different angle. What about the future integration of satellites in 5G and IoT network architectures, in terms of interoperability with current 3GP connectivity solutions?
I can take that one. This is Ken. Oh, go ahead, Mike.
No, I was just going to say from a IoT use case perspective, I think satellites are going to, satellite communications is going to be, an important connectivity solution. And I think, I know from a service layer perspective, that's not an issue for integrating, aggregating different connectivity technologies into one service layer. But maybe, Ken, you can have, maybe there's a tie with 3GPP as well.
Yeah, I think they're looking at all different ways to deliver 3GPP technologies. It could be satellites that are used by airplanes, and also even drones. I'm in North Carolina in the U.S., and we got hit by 2 hurricanes the last couple of months. And what we've seen is the network operators would put up these drones for 12 or 18 hours. They're cable drones into the sky to work as cell tower replacements. And so it's really amazing how much uptime we see with cellular technology. And so I think these portable towers with drones, I think satellite, all those will be a part of delivering a robust ecosystem with the years to come.
I mean, along those lines, another question was, are there any standards for IoT using satellites?
I don't know that. I don't know that off the top of my head. I know there's companies that are focused on satellite communications.
Right. I mean, certainly the satellite operators. I mean, there's a the holy grail has been for a long time that potentially 2 things coming together: the creation of nano satellites, these sort of like 5 inches by 5 inch type satellites, and low cost delivery mechanisms, like the Virgin X and SpaceX and whatever, can sort of coat the skies with satellites at low cost, and then theoretically, you've got a situation where you can now sort of provide ubiquitous coverage, but then obviously it's something that it still needs to be sort of viewed as an integrated part of 5G, and obviously 5G is heterogeneous, but it's not something that's out there at this point of time. At least I haven't seen it. Will broadband, narrowband quality of service, priority and preemption functions work the same way for IoT-based transport with LTE Cat M1 and LTE Cat MB1?
Yeah, I can take that one, Steve. Today, the standards that are built into 3GPP, a lot of those are used on the public safety side. Those are really focused today on Category 1 and above. There are provisions being added into 3GPP to allow those same capabilities on Cat M1 and Narrowband 1. So yes, that is definitely being built into the 3GPP standard.
Okay. There was a comment. It's interesting. Would smart home be dominated by Wi-Fi as the access technology? And I think Wi-Fi is an interesting area from two aspects. I think one is it's started to get a placehold in automation in factories, but I know that a large number of companies are starting to look at that as an entry point to provide LTE private networks as a mechanism for providing IoT solutions. And in the home, I think also, the whole concept of moving towards the sort of the sort of smart antenna and very small micro hubs makes it an interesting overlap space with Wi-Fi in the homes. At least that's what I'm seeing. I don't know about you guys.
Yeah, absolutely. I think, there is some overlap happening, and it's all about, user experience. There's certain devices, say you take a coffee maker, for example. That coffee maker, if you want to set it up with the Wi-Fi access point, username, password, and all that stuff, that's definitely one way to get the coffee maker connected. The other way is to put cellular inside where it works out of the box. There's no configuration needed. So it's really going to depend on the value and use case. We see things of high value using cellular because they're not reliant on the home access point being set up and the uptime associated with it. So it really depends on the use case. There's definitely a spot for both Wi-Fi and cellular. It really depends on the outer box experience that you're looking for.
Right. Well, thank you, gentlemen. We're just at the top of the hour. I'd encourage our audience to please take the survey that's on your screen. It helps us provide you with the relevant topics and the best service. So I would appreciate your participation. For Mike and Ken, thank you very much for your perspectives on IoT. I think that there's a huge opportunity going forward. I think the new technologies and the new platforms and the new generation and migration offer up huge opportunities for use cases that most of us haven't actually seen and thought about up until now. So thank you both gentlemen for a very interesting webinar, and with that, thank you, the audience.